Wow, look how neat nature is.
You could tell it's an aspen because of the way it is.
How neat is that?
Ah!
Wow, I wish I had binoculars to look at the cell structure of this plant. Did you know lobsters have cells too? Lobsters come in many different colors!
Hey, Mom. What? No, I told you I was going exploring. No! Okay, yeah, still pick me up from Rita's.
Hey! Look at this! Wow, dude! Nature sucks.
Yeah. Do you know, ocean acidification affects a lot of water.
Here, American lobster. Here, chippy chippy. Here, chippy chippy. Here. Here, chippy chippy. This sanctuary is dedicated to the American lobster.
No, okay.
This year's sanctuary is dedicated to the American Lobsters Associate's degree in economics.
Make a wish for American lobsters.
Ocean acidification. What is it? When carbon dioxide has mixed with other water molecules to form hydrogen ions and carbonic acid, those available hydrogen ions bond with other carbonate ions to form more carbonic acid. This lowers the pH in the ocean and affects aquatic animals due to the change in environment. The problem here is that marine organisms possessing shells, like crustaceans, need available carbonate ions to form the calcium carbonate that comprises their shells. In essence, ocean acidification is robbing these organisms of the necessary building blocks.
The American lobster can be found on the east coast of North America. Small lobsters hide in and around seaweed and rocky habitats that provide food and shelter. Adolescent lobsters dominate coastal habitats and offshore areas. Larger adult lobsters live in deeper waters but return seasonally to shallow, warmer waters. Adult lobsters generally live in depths of less than 50 meters. Lobsters prefer rocky bottoms covered with algae. This kind of habitat offers many cracks and shelters in which a lobster can hide. When there are no cracks or algae to shelter, lobsters dig burrows. Adult lobsters can often stay close to the coasts in the summer because of the warm water, and then they migrate to open water in the winter to escape turbulence. A lobster's life cycle in growing is achieved through molting. In this process, they struggle out of their old shells while absorbing water, which expands their body size. After molting, lobsters will eat more than before, often consuming the shells that they just shed. This replenishes lost calcium and helps harden their new shell. This molting or shedding occurs about 25 times in the first 5 to 7 years of their life, resulting in a lobster weighing approximately 1 pound. Lobsters reproduce sexually, starting with a lobster egg, which is the size of the head of a pin, laid by a female lobster who can carry approximately 8,000 eggs. Larger 9-pound females may carry more than 100,000 eggs. The female lobster carries the eggs inside for 9 to 12 months, and then for another 9 to 12 months externally attached to the swimmerets under her tail. Internal features include a heart on their back, behind the cephalothorax, just before the abdomen, and 2 stomachs, located in the lobster's head, behind the eyes and brain, and another in the abdomen. Some external features of an American lobster include 3 pairs of antennas, which are sensory organs used particularly for touching and allowing lobsters to find their way around their environment. They also have claws. One is used to crush, and the other is used to cut. Some of the predators of American lobsters are mainly humans, crabs, seals, and many ground fish such as flounder, cod, and rock gunnels. Lobsters are heterotrophic and usually move around and hunt for food at night. They are also opportunists, catching mainly fresh food, which includes small fish, crabs, clams, mussels, and sea urchins. Lobsters are also cannibalistic and sometimes will eat other smaller lobsters if needed. Some of the current effects on the habitat are changes in the quality and effects on other ecological processes, such as nutrient cycling. Many of the psychological changes from ocean acidification are expected to affect key functional groups, such as species or groups of organisms that play an important role in ecosystems.
Recent short-term studies have shown the exposure to low pH water over a 60-day period that may result in increased calcification rates and thicker shells in juveniles. However, it is unknown how this response could affect key demographic processes such as growth and reproduction, which is crucial to the species, or if the same response will be expressed by lobster at other stages in life.
This also affects their diet by killing phytoplankton, who serve as the base of marine food webs. Many marine organisms, such as sea urchins and plankton, which are prey for the American lobster, rely on an equilibrated chemical conditions and pH levels in the ocean to build their calcium-based shells and other structures. Possible long-term effects on the habitat is that ocean acidification is harmful to plankton, corals, shellfish, and the marine ecosystem. Decreasing carbonate concentrations in seawater make it more difficult for marine life to build their skeletons and shells, a process similar to osteoporosis in humans. More acidic oceans cause increased dissolution and erosion of skeletons and shells, which compromises the survivability of organisms that depend on these structures for protection and proteins. Any reduction in plankton numbers will likely have a significant impact on marine life, which depend on them for core functions. Long terms of ocean acidification on their diet are predicted that by 2100, ocean acidification will have grown to such an extent that some species of phytoplankton, who supply half of the world's oxygen and are the base of the marine ecosystem, will die out.
To study the effects on larva carapace length and molting lobster larvae were reared from stage 1 and either acidified pH of 7.7 or controlled pH of 8.1 seawater. Organisms in acidified seawater exhibited a significantly shorter carapace length than those in controlled seawater after every molt. Larvae in acidified seawater also took significantly more time to reach each molt than the control larvae. The acidified treatment by bubbling CO2 enriched air into replicate experimental containers was seawater and larvae, while the control treatment was created by bubbling ambient air into other containers was seawater and larvae. After 40 days, larvae in low pH water exhibited a shorter carapace length than those in controls, suggesting that lower growth of the larvae, which could indicate longer time to reach maximum marketable size and sexual maturity. Larvae in acidified water also took more time to reach each molt 1 through 4, and some larvae did not reach molt 5 by the end of this experiment.
One alternative to the non-renewable energies which cause ocean acidification is wind power. Wind power. The first windmill was used in the production of electricity in Scotland in July 1887 by Professor James Blyth of Anderson's College. What is wind power? Wind power is the use of airflow through wind turbines to mechanically power generators for electricity. It is an alternative to burning fossil fuels because it is renewable, widely distributed, and produces no greenhouse gas emissions during operation. Wind farms consist of many individual wind turbines, which are connected to the electric power transmission network. There are multiple types of wind power. One is onshore wind, which is inexpensive and is cheaper than coal or gas plants. Another is offshore wind, which is steadier and stronger than on land, and offshore farms have less visual impact, but construction and maintenance costs are considerably higher.
Wind power's carbon footprint. Based on the studies examined, wind power emits an average of 34.11 grams of CO2 per kilowatt per hour over its lifetime, with a low estimate of 0.4 grams and a high estimate of 364.8 grams. In 2015, wind power represented almost 5% of the total electricity generation with an installed capacity of over 70 gigawatts. That's enough to power over 18 million homes. What are the positives to wind power? It is a clean fuel source. Wind energy doesn't pollute the air like power plants that rely on combustion of fossil fuels, such as coal and natural gas. Wind turbines don't produce atmospheric emissions that cause acid rain or greenhouse gases. Wind is a domestic source of energy. The nation's wind supply is abundant. Over the past 10 years, cumulative wind power capacity in the United States increased an average of 30% per year, outpacing the 28% growth rate in worldwide capacity. Wind power is sustainable. Wind is actually a form of solar energy. Winds are caused by the heating of the atmosphere by the sun, the rotation of the earth, and the earth's surface irregularities. For as long as the sun shines and the wind blows, the energy produced can be harmless and send power across the grid. Wind power is cost effective. It is one of the lowest priced renewable energy technologies available today, costing between 4 and 6 cents per kilowatt hour depending upon the wind resource and the particular project's financing. Wind turbines can be built on existing farms and ranches. This is greatly beneficial for the economy in rural areas, where most of the best wind sites are found. Farmers and ranchers can continue to work the land because the wind turbines only use a fraction of the land. Wind power plants only make rent payments to farmers or ranchers for the use of the land, providing landowners with an additional income. Wind power creates jobs. In 2014, the wind sector invested more than $8 billion of private capital in the U.S. economy to build projects and employed more than 73,000 workers. Wind power also has its negatives. Wind power must still compete with conventional generation sources on a cost basis. Depending on how generic a wind site is, the wind farm might not be cost competitive. Even though the cost of wind power has dramatically decreased in the past 10 years, the technology required a higher initial investment than fossil fuel generators. Good wind sites are often located in remote locations, far from cities where electricity is needed. Transmission lines must be built to bring the electricity from the wind farm to the city. Wind resource development might not be the most profitable use of land. Land suitable for wind turbines installation must compete with alternative uses for the land, which might be more higher value than electricity generation. Turbines might cause noise and pollution. Although wind power plants have relatively little or no impact on the environment compared to conventional power plants, concern exists over the noise produced by the turbine blades and visual impact to the landscape. Turbine blades could damage local land. Birds have been killed by flying into spinning turbine blades. Most of the problems have been resolved or greatly reduced due to technological development or by properly sitting wind plants. Birds, bats, and other flying creatures have slim chances of surviving when taking a direct hit from a rotating wind turbine blade. However, some environmentalists have blown this issue out of proportion. Studies have estimated the number of annual faulties by the U.S. wind turbine from 10,000 all the way to 440,000. As a comparison, collisions with buildings may kill up to 976 million birds.